This is pretty new territory, especially in the state of Colorado. These are some of the first of this style, what they call process-based restoration or low-tech restoration, some of the first of it in the state. My name's Tim Fegel. I'm originally from Grand Rapids, Michigan. I went to CSU and did my master's in the graduate program in ecology back in 2013. And now I'm back at CSU a decade later. I'm doing a PhD in soil and crop science. There's been increasing fire activity over the last couple decades here on the Front Range of Colorado and in the western United States in general. And between the two fires, we have about 60% of this upper watershed has been burned now. And so that's pretty dramatic effects on how this watershed works. So much of the treatment in the post-wildfire is like throw mulch on the hillside, plant trees on the hillside, and it gets, per acre, gets really, really expensive really quickly, you know. What these features are is, this is timber that's been cut from the surrounding hill slope, and it's been used to kind of put in the channel to increase channel complexity. One of the biggest impacts of these systems is hopefully watershed resilience to wildfire. And it actually didn't take that much cutting to make, you know, they harvested, I mean, where you can see the kind of the green in the treetops, they harvested there down over here. Not a very big area that they used to create 22 features in the stream. Kind of impressive. Not only are you using lumber that's of very little value to make stuff that's going to be of value here, but you're also thinning fuels from the hill slope right around it. So you're actually creating another increased barrier for fire if it were to come through here to kind of protect it. Historically, these were wet meadows, but then, like I said, with grazing and removal of the beaver, it's kind of created kind of more of a pastoral environment for grazing. And so it creates a wetted, greener area where we can have both a fire break and a place for animals to come and kind of hide themselves if there were to be another fire. And so this is an area where we're actually measuring discharge within the stream channel. Water actually feels nice now. These little silver tubes that we have in the well, it's just measuring pressure. And then we have a game camera right here just sitting. We measure velocity, but then we can calculate how much water is actually coming in per amount of time. So we'll do it up here, and then we do it at the base too, so we can see how much water is coming into this meadow, how much gets dispersed out into the floodplain, and then how much is actually coming out at the bottom. Is the water staying in the floodplain, or is it all just kind of going out but then coming back in? Thank you, team. Distance of 140. Depth of 3.1. I'm gonna go down to my redox sensor and download the data. So this means a lot of things for the dynamics of how the microbes that are living in the subsurface, how they're gonna process carbon and nitrogen and phosphorus and all these elements that are coming in. Capturing sediment, carbon, all that here, hopefully that mitigates it from moving downstream to where municipalities and water users need to take it up and have to deal with that with water treatment options. So hopefully these can act as kind of a natural biological filter for that. So this goes down about 1 meter right here. And then I have my logger for it over here. That's that. A bunch of numbers that will go analyze back at the station. Watersheds kind of work like capillary beds, right? Like you have the big artery at the bottom, but a lot of the interaction, like in our bodies, right? The little watersheds that are higher up in the systems, that's where a lot of the interaction with the terrestrial environment happens. That's where a lot of that connectivity from what's happening on the hill slope to what's happening in the stream, it's all very connected up there. The biggest water storage in the western United States is groundwater. And so the more of those little features you have up higher in the watershed, where they're raising that water table, increasing that soil water, that's where the water is stored. And so I think they could have huge benefits from those smaller features.